In this video, I'm going to show you how to use the sine rule to find a missing angle. So what we have here is a triangle. One side is 10.8 centimeters long. This one is 18.5 centimeters long. We know this angle is 30 degrees and this is a mystery angle theta. Notice we are not told if this is a right angle triangle or not, so we can't assume it is. So we can't use SOHCAHTOA and we cannot use Pythagoras' theorem. To use the sine rule, we have to see if there is a pair of angles and sides. What I mean by that is, here's an angle that I want, and I know the side across from it. So that's one pair. And then I need another pair where I know a side and an angle across from it. And the answer is I do have that there. So the sine rule looks good. When we're working out angles, we use the angle on top version. So when you're looking for an angle, use sine A over A equals sine B over B equals sine C over C. In the previous video, we were looking for a side and we used the side on top version. So here, I'm going to jump straight in. I'm not going to bother with A, B's and C's. I'm just going to start off with theta. So I'm going to say the sine of angle theta divided by its side, which is 18.5, is equal to sine of a different angle that we know, 30 degrees, divided by its side, which is 10.8. And we have an equation. Now, with the angle ones, we're trying to get sine theta on its own first. So sine theta. To get rid of a divide by 18.5, we bring it over and multiply it. So 18.5 times the sine of 30 degrees over 10.8. And I'm just going to write sine theta equals. And what I'm going to do is type this into my calculator. So I'm going to put a fraction, 18.5 sine 30, an arrow down, and on the bottom I'm going to put 10.8. Double check that that's what's here, and then press equals. Now, it gave me a fraction. We have a choice. We can leave it as a fraction, 185 over 216. So we can write 185 over 216. Or you can press the SD button, whichever you prefer. However, if you're going with decimals, I want you to leave a load of decimals in, at least 4 decimals to keep it accurate. So it's 0.85648. I'm going to put 0.8565. 0.8565. So at least 4 decimals if you're going to leave it as decimals, because we're not finished yet. Now, to get theta, that's what sine theta is equal to. To get theta, we have to get rid of a sine by getting the sine inverse of 185 over 216. Or if you prefer decimals, it's sine inverse of 0.8565. So whichever of those you prefer. I'm going to do the fraction version, so I'm going to go shift sine fraction. I got 185 over 216. Oops, arrow out first and then close my bracket. And when I'm happy, press equals, and I'm getting 58.92 degrees. Now, so 58.92 degrees. Now, the question wants it to the nearest degree, so I'm going to put my answer as 59 degrees. So I've just worked out an angle using the sine rule. I'll do one more example of this. Here is another example. The only difference here is it has square roots and stuff in it. Don't be put off by that. Okay, so our job is to get theta to the nearest degree again. So please note that theta is here, and it matches up with a side here that we know the length of 10. And we know another angle, 60, matches up with this guy here. Because I'm looking for an angle, I'm going to use the sine of the angle on top. I'm going to say sine of theta divided by 60 degrees. Sorry, that's wrong. I'm going to put sine of theta divided by its side, which is 10, is equal to the sine of 60 over its side, which is 10 root 3. Okay. Now, like the last example 3, we want to get sine theta on its own. So to get rid of a divide by 10, we multiply by 10. So it's 10 sine 60 over 10 root 3. And at this stage, we just type this into our calculator. So 10 sine 60, close bracket, over 10 root 3, 10 square root 3, press equals, and up comes a half. Okay. Now, or 0.5, and then theta, the last step with angles is you have to get sine inverse of a half. And we can do that in a calculator. We can go shift sine our answer key, because it was a half already on the answer, and I'm getting 30 degrees. So the answer here is 30 degrees for this one. So there are similar questions and examples in your book, and please have a look at them and try them.